Hello and welcome to the pilot episode of the My Two Quantifiers podcast. And today we have a guest with me. His name is Wally. And we will be talking about neuroscience. I think if one looks at the history of every science, there have been major events which shaped our understanding of it. And obviously, extrapolating these, there will be even more events which will probably change our understanding even more. And so I would like to ask you, Wally, as some sort of familiar person in this field, whether you can tell us something interesting about it.
Well, first of all, it's a vast field, and my approach to almost every field that I come to is always historical. And Western neuroscience really, the beginnings of, if you can call it scientific age, well, it's not scientific, but proto-scientific, really starts with Aristotle. There was obviously Aristotle was interested in biology and philosophy, and he was the universal philosopher. And his interesting postulate that went for a while. The ancients debated what the brain did and what it was for, and to Aristotle, the soul or the mind or the human and to what was in the heart. And that's why we get all the expressions, pull the heartstrings or heartache, etc. And that's understandable that when we feel emotions, we do feel it in our chest, we feel our heart race and slow down. So the thought was that the soul and the mind was in the heart, and obviously the liver, and the spleen was important for anger. And Aristotle postulated that the role of the brain, when he examined the brain and saw the convolutions, that the convolutions were to cool the brain, to cool the blood, that the blood circulated from the heart and out to the brain, and part of the function of the brain was to cool the blood. Then there were of course, the Egyptians were involved before that, and I don't really know their thoughts. I hadn't gone into what the Egyptians had thought, but they obviously influenced the Greeks. Then later on, it was, Galen and others realized that the brain was probably the organ of thought. But then the debate was whether it was the brain or the ventricles. And for a long time, the fluid in the brain was thought to be where the soul and the mind sat and it was the flow of the fluids in the brain that actually created the mind and the function of the brain. And it was not till Thomas Willis, who is sort of the first Galen was really the first who studied the brain in what we'd call a scientific manner. And then in the Renaissance, it was really Thomas Willis who postulated that the brain was actually the seat of thought and the ventricles were not where the thought was. So it really, so modern neuroscience really starts with Thomas Willis, and then there was anatomical progress, and then the discovery of electricity, and there was various postulates as to how the brain worked. The next sort of famous person that we still refer to in terms of the working of the brain is Descartes, who postulated that there was a direct connection, that the nerves were tubes by which fluids flowed to and from and to the muscles, and that's how and the muscle inflated, and that's how we moved, and that because we had two sides of the brain, and it operated on, they knew that it operated on the opposite side, that if you damage one side, the other side wouldn't move. He postulated that the seat of the soul was in the pineal gland. That didn't last, that wasn't accepted. And then really in the 19th century, there were all sorts of hypotheses as to how every time humans had a great invention, they postulated that's how the brain worked. And the first metaphor for the brain was actually an irrigation system, that people thought that the thoughts and everything were transmitted around like in canals in an irrigation system. And the next sort of metaphor they used was the church organ. Now, the organ, most people don't realize that the church organ, or the organ, was actually invented in Roman times, I think around 200 BC, in fact. And that's where expressions like pull out all the stops and came from. So people thought, the brain is like an organ, and the god or the soul is like an organ player, and you pull out the whistles and you make it all work like an organ. But then, sort of coming into really the 18th and 19th century, and with the rise of the Enlightenment and the discovery of electricity, then we sort of get to the modern ideas of the brain. And the next step was really that there was in the 19th century a debate between localizationists and the generalists. So some people thought that the whole brain operated as a unit, and others thought that that different areas were responsible for different parts, and it was really the phrenologists. Phrenologists were people who said that different parts of the brain did different things, and that those parts that were developed, you'd get bumps on your head. So they would analyze bumps on the head. This was sort of considered a pseudoscience in some circles, but it was the sort of start of the localizationist idea. And that debate went on until the 1860s, when a French surgeon called Broca had a patient on the ward who lost his power of speech, and all he could say was "tongue, tongue," and so they called him Tongue. And then he eventually died, and Broca cut up his brain and realized that the area that was damaged was in the posterior frontal upper near the temporal lobe area, which is now called the Broca's area. And that was the only part of the brain that was damaged. And he postulated, and it was strongly supported, that that's the source of expression, of speech. And that's from there on, the localizationists ruled that everything was trying to be attributed to a particular area of the brain. And then we come into the 20th century and the neuroscience flowering, and there are many fields. And in discussing neuroscience in the 20th century, we could break it down into many areas. The sort of biological, which is what I've been talking about, the biological neuroscience, which is kind of medical neuroscience, and the working of the brain and how it goes wrong, has that sort of really flowered in the earlier 20th century, based on just diseases and injuries to the brain, and then noting what deficits developed. But that's a sort of a biological, neurological neuroscience. But you can discuss many aspects of neuroscience. I mean, just we can talk about neuropharmacology, neurochemistry, the neuroimmunology. Then, of course, there's computational neuroscience. There are so many subdivisions of it, but sort of there's some of the areas that one can talk about. I mean, and it's what I've been surprised is how much the neuroscience has really been emulated in the last, well, since the discovery of since the development of the computers, and how much of modern computation, particularly AI, is actually an emulation of as we understood the workings of the neurons and the brain, how much it's being emulated. And that's that's interested me quite a lot. And again, I've sort of talked about the metaphors that people use for explaining the brain. Some of the other metaphors, as history has developed, I've told you about the metaphor of the church organ. Another metaphor that people used was that the brain was an orchestra, and there was a conductor, and it was a symphony. And then with the rise of the industrial,
And who was the
the
conductor?
conductor was the soul, or somebody in some sort of homunculus in the brain, which was the consciousness. But I know you go into our infinite regress there, but that was that there was some sort of a consciousness or conscious or something that called the working. I mean, it's a rough idea. That was the thing. I'm just going through other metaphors which are interesting. Then with the Industrial Revolution, it came the other metaphors that were used, like it was an engine, and that's where we get it was a steam engine, and that's where we get the things of I feel pressure and tense, and those metaphors we used. So, and then then the mechanical metaphors, that it was a machine, that everything interacted mechanically at a microscopic level, which we couldn't figure out. And then the next big one was the invention of the telephone. So the brain became a telephone system, and then a telegraph system, that we were sending impulses like telephone. And then, but it was more than that. So it became a telephone exchange. And then, of course, when the computer was invented, in fact, computers were called artificial brains. And so we've gone further, and now people say the brain is like the internet, or is the internet, and that internet will eventually become conscious, just like if it develops the complexity of the brain. People say, well, it's the brain so. But this history of we invent something or develop something and then use it as a metaphor of how the brain works. Of course, the brain is not an internet, and it's not a computer. It is something else, and I'm not quite sure what it is. But we've used aspects of the brain to. Certainly, it's been used since the development of computers, in my opinion.
About that, actually.
Yes,
So
no,
sorry for interrupting
sorry,
you
I've gone
here.
on a bit, but that's sort of I've tried to be a potted history, if you like. Yep,
No, it's been a great overview. And just
yep.
a few questions that I managed to snatch along. So you obviously showed how our understanding of brain progressed from Aristotle into the Middle Ages and into the modern times, and obviously changed radically, like you mentioned, starting from the tubes and the orchestra and the irrigation system. So obviously now it's more driven by chemistry and
Yes,
electricity in some
yes,
sense, right? So we have the electrical signals which are passed along, and we have the chemicals
yes.
which are activated or activate these signals. Now, how do we know that something like this is, in certain sense, related to truth? Why is this not just another irrigation attempt with tubes, or, as Aristotle thought, just a cooling system?
Well,
How do
there is a
we?
debate. There are some
How do we?
people in different areas who actually say that quite rightly that the brain is merely a conduit, and there are people like Roger Penrose says that the chemistry and the electricity will not ever yield a consciousness, that it's all at a quantum level, that there are that the real deep brain is quantum level. And there are some people that say that it's just like how would you put it, like a viewing station for the greater universal consciousness. Now, these are people that conventional science sort of disagrees, but some of them are really quite erudite, and we can't dismiss them as crazy. But it's to me, it's a crazy idea that the brain is not a unit that does that. That these are all that what we see, and it's important, but it's not the actual brain, if you like. It's either a receiving station, is what some people think of it as, or a endpoint, or a one station in a great web, which is part of the universe, and some people, and part of the quantum fields, and etc. So there's a sort of the person that I can kind of read, and I don't agree. He wrote The Emperor's New Mind, which is Roger Penrose, and he has been, I mean, he's a smart guy, and he's one of the sort of leaders who in that sort of area. So yeah, you're quite right. Some people do not accept that all of the physicality of our mind and intelligence. They don't accept that the brain is the end of the story. That what we know now, obviously, it's not the end of the story, but that what we know now is sufficient. That the mechanistic, if you like, I'm using mechanistic as in terms of physical, like a physicalistic explanation of the brain is sufficient.
What would you say to the point which probably should be raised is that there's been a lot more experimental evidence for the models of a brain which we have today compared to the models that Aristotle used, who famously said that heavier objects fall faster than lighter, but he didn't even bother testing this claim.
Well, he couldn't
Systematically.
Greeks were not experimenters. They were philosophers. They liked to postulate. Although Aristotle was probably the first observer, although Pythagoras was too, but they were not really experimentalists, and nor could they have been, I guess.
But so what evidence, let's say, in this specific case, do we have that the brain is more really like an intertwined system of chemical and electrical signals rather than an irrigation system? And that it really controls our thoughts and consciousness instead of just cooling the heart.
Well, I mean, the lot of the studies have came through neurology, basically that deficiencies, like Broca's first clinch that there was a spot in the brain, an area of the brain not very big, which was absolutely critical to language, without which there was no expressive language. And then coming through that right since the 1860s, areas of the brain which are absolutely essential for certain functions. There's mesial temporal lobes. If you cut them out, there's no memory. No new memories develop. If you take pieces of brain out from anywhere, gradually the person's memory declines. And that indicates, although there's a critical area for memory formation, the memory is completely distributed through the brain, and diminution of the physical amount of the brain damages the memory. So there is a lot of evidence that, I would say everything that I have seen, that people see, and that people who study this, is explainable on the physical, chemical, electrical basis that we have now. Now, we can't explain it perfectly, but both in terms of positive actions and in terms of deficits, you can see it's all I think all explainable. There is no need to hypothesize another completely different entity. Using Occam's razor, you really to postulate either quantum effects. Now, there is a huge. The best thing about argument that I've seen for quantum effects being important in the brain, and it's not just purely chemical, is, and I don't know if it'll turn out to be true, and I think we've talked about it before, is the migratory bird navigation, that there is some evidence that there is in migratory birds that they can perceive the magnetic field because, and I'm not, this is obviously, I don't understand it fully, but apparently magnetic field, I don't fully understand it, but that they have an organ in the eye or chemical in the eye that can perceive photons, or are they positrons? I can't remember, but there's I think it's positrons and electrons, and that through with this organ, the best explanation, there's a lot of experimental evidence that they can actually see the magnetic field and that it's a quantum mechanical effect. And obviously, I mean, our vision is a quantum mechanical system, quantum system, in that photons impact on the retina, and the photon alters the visual perception protein, which we then perceive. But the postulate, and there's lots of good evidence, you can look it up, that these migratory birds have this ability to perceive the magnetic field as a result of some quantum effects that the magnetic field produces that non-migratory birds don't have. So there is some evidence for quantum effects, and that's the only one that I really am convinced about, or sort of convinced. But to hypothesize sort of I mean, people have looked at the big wide field Hubble and wide field James Webb telescope and have said that if you look at a very, very wide field and the strings between groups of galaxies and you look at a field of neurons, it looks very, very similar. Obviously, that's a great leap. But if you do look at those wide field, low magnification neurons and a wide field picture of the universe, it looks amazingly similar. Now, the romantics amongst us just love that sort of thing, that really the universe is just a neural network.
But doesn't this boil down to the same things you mentioned historically, where people have to think, well, people had objects in their surroundings which were newly invented, and then they tried to explain everything using the object.
Exactly right. As we did.
So now, because quantum mechanics is a relatively recent invention and it's been applied more and more, everything is trying to be, or like the brain in this case, is trying to be explained using the quantum mechanics.
Yes, that's what I wanted to see. Humans have this. Everything that's new, the brain is like that. And now at the moment, it's neural networks, AI, we're going to build a new brain, and the brain works like that. But it doesn't work like that. It is...
Yeah, I've actually also... so when I had this topic in my class as well, the original invention from the eye who...
Hebb.
Unfortunately, I don't remember his name, who got the physics Nobel Prize.
Who got the idea of neural. He had the expression that neurons that fire together wire together, and that the more they fire together, the stronger the synapse connection becomes, and that's really the basis of neural networks.
I was thinking John Hopfield in this case, right? John Hopfield, who got the physics Nobel Prize for inventing neural networks.
Oh yes.
Yeah, obviously his original neural network was inspired by the grid cells.
Yes.
In the brain, but his original the original neural network which he came up with, which is known as the Hopfield network. Well, I'm not a big expert on this, but as far as I remember, it's just a circle of neurons which are all interconnected together, which is really not much to do to the artificial neural networks which are used today. So if the inspiration from the brain was obviously there, but I think it's a big stretch to apply modern models to
I
the
tried
brain,
to program a few little 3-layer neural networks. I fiddled with it for years. It really all it is. The neural networks are based on one hypothesis, that the synapses, that's the junction between neurons, are malleable. They change with every function, every action of the neuron, and that's what training a neural network is. You are changing the weighting between one neuron, one action and another. And that's it really is. The hypothesis is that the synapse changes with experience and with and learning and whatever, and it does. And there is very good evidence. The study of memory, the biochemistry and molecular biology of memory, is well studied. I mean, Kandel won the Nobel Prize for really working out the chemistry and the genetics of it. So it is the strength of the synaptic connection is altered by the function of the neurons. And as far as I understood it, and the toy neural networks that I fiddled with, that's what I was trying to do, is to get feedback so that the strength of the connection between the so-called neurons would change. That's my understanding of it. Now, of course, there's been much tweaking and much alteration, but the basis of it is that. And the difference. We've talked about Marvin Minsky. Marvin Minsky and a guy called Papert in the early 70s or late 60s, because the neural networks were going to be big. Started in the 50s, and they had a three-layer. I think it was a three-layer network, and they were called perceptrons. And Marvin Minsky and Papert proved that perceptrons, as they were, wouldn't lead to anything, wouldn't lead to AI, because. And Marvin Minsky said that to build some using that system would require what in the 70s was impossible number of neurons, like billions and billions of connections, and said it was impossible at that time, and he postulated that it was never going to be possible. And that's why neural networks went out of fashion, but Moore's law caught up with it. And so in the 90s, people said, oh, well, it started to come back, that it was becoming practical. Okay, to answer your question, in my thought, the synapse is the key to the neural networks of computing. And I may be wrong, but that's how I understand it. And it's basically changing the strength of the synaptic connection through the experience of the system. So the more it fires in certain ways, the stronger the connection. I mean, each of those things, as far as I can see, is sort of an integration. And now they have, 40, 50 layers, and I don't know how many billions of connections. That's how they've achieved what they have. That's how I see it. And it comes back.
Yeah,
Hebb is the critical guy, I think, who observed or postulated this. He didn't build it. He was a psychologist. He was an interesting character, though. He was a Canadian.
Now, coming back to the brain, kind of where we all started. Obviously, as we have shown before, as we have talked about before, current model of the brain is expected to be a lot more stable than the previous ones with respect to change, due to primarily experimental evidence, since this is the only thing that we can use aside from some sort of philosophical arguments to verify its validity. Now, nevertheless, this is something that is probably changing and has changed in the recent decades as well. But I would guess that the public understanding of the brain is obviously lagging behind the most modern understanding in neuroscience. Just like it takes time until this knowledge propagates into the school program and catches up with everybody. So if that is indeed the case, is there some significant, in your opinion, when you talk to people, is there some significant misunderstanding about the brain function which is prevalent in current society? Yeah, which is already kind of been either disproven or strongly believed to be disproven, and is some sort of a retrograde or fact or a rudiment of the past.
Well, I think it's still way too the general understanding of the brain is still very, very mechanistic and very, very simplistic. And even the advanced supposed computational neuroscientists, some of whom have actually done neuroscience, uh, uh, is far, far too simplistic. See, the brain, people talk about, I don't know if you heard the expression, the brain in the vat, and that you could isolate the brain and feed in signals. The brain is really not the brain. The whole body is part of the brain. The brain has receptors and outputs which feedback on it throughout the whole body. I mean, if you have a toothache, if you have a sore tooth, your thoughts will be completely different. I mean, the whole autonomic nervous system, which is outside the brain, although the center where it's thought of has a center in the hypothalamus, it's all part of the brain. And you can even go further and go into the sort of metaphysical, where actually your society you grow up in is part of your brain. I mean, the language you learn is not, it's you're embedded in the whole society. So you can have an extended view of the brain. I think the brain is central to the neurological thinking, but but the brain is not isolated. It swims in a pool of incredible number of chemicals and hormones and glucose levels and everything, all of which influence every nerve and every signal, and also the environment and the fluctuations of the emotions, whatever they are. So this, so the simplicity, and I blame Descartes really in that he made it into a machine, and and everybody still believes that it's a machine. It's really not a machine. You can say, oh well, we can simplify it, and it's a useful metaphor. It really is. It really is a useful metaphor up to a point. Beyond that point, it's really distracting and destructive. Um, and sort of the expectations and the okay, I'll use a simplistic thing. Our favorite billionaire of this age is Musk, and he's got this neural link going. In my opinion, it's the most ridiculous thing I've ever heard of. But I think that's a minority opinion in this stage, and given Trump, Musk's history, I'm putting myself out on a limb, but I think the whole idea of that neural link is madness, insanity, delusions of grandeur, because the brain isn't like that. That's based on a very simplistic model. The best, I like this expression. The best expression, I think it was a French, Jacques Changeau, I might be wrong, who said, if the brain was simple enough to understand the brain would be too simple to understand.
We would be too
Yes.
simple to understand. Yes.
So,
Yeah, I heard this
yeah,
expression.
so yes, the metaphor. So, what is the general understanding? I mean, to me,
But isn't it some sort of a counterproductive argument you could use? Because generally, I guess no one person can understand the brain, but I guess maybe because if this limit argument exists, but you could make a claim that you could dissect the brain's functions into, I don't know, 100 different areas, and each area will understand this tiny part of the brain. Just like today, nobody understands the whole of neuroscience, nobody understands the whole of mathematics. Nevertheless, each part of mathematics or each part of neuroscience is understood by at least, or like to an extent that it's known, is understood by at least one person. So the fact that we could never understand the brain,
but the brain,
due to
the
limitations
problem
of our
is
own brain.
that was my initial, that there is a localizationists and the generalists, and the brain has both, and you can't. It's not it's not built of pieces. It's not okay. You can say the visual system is in the posterior occipital lobe, but it's not. Yes, there are neurons there that react, but the visual system. Okay, what you see is in a large part an input. There's an input and an anticipation. The brain actually produces your vision. Yes, there is a stimulation of the light that stimulates it, but it's been very well shown that all parts of the brain contribute to what you actually see. And unless you're prepared or anticipating, or if you are anticipating how differently you will see something. So the production of every thought is not just the stimulus, this that it's a reflex and it produced, and you put a light there and you perceive the light. No, it's not like that. The brain is actually involved in constructing. It actually constructs what you see, and how you see it and how you interpret it. I mean, just like we're speaking in English, we can only say things in English, but that's not the brain. That's just our enculturation. I don't know if I'm explaining that very well. I don't think.
No, I understand the argument. I guess it's kind
Yeah,
of
well,
philosophical in a sense, right?
this is where I get. This is where the philosophers and the pseudo philosophers take over, and there's a whole massive literature out there. Uh, People sort of arguing things which really, in my opinion, most of them are not really, have not enough understanding to be really arguing, but they're coming from a philosophical or a sociological or a computational or whatever field, and then they insert their biases onto it. That's my cynical.
But this is how the progress
Yeah.
is made in a sense, right?
Yes.
So some other field inserts itself into the other field, and then suddenly the ideas are useful, just like the ideas from medicine, from neuroscience,
Yes.
made it into computer science. So I don't think we should discard it just on the basis.
It's very interesting, and
that.
I'm always very keen to read these, and then I get the book, and then I read it, and I think, oh God, no, this is too much. I can't bear it, because it's sort of, if you read ancient science, if you like, ancient books, and they're postulating how the world works. I mean, just simple thing like astronomy and how and we know that it's not like that anymore. But they were doing their best, and I think we're still at that stage with the brain.
Fascinating. I think this is a good point to end the debate and to maybe say a few words in conclusion. I don't know if there's something you would want to mention before we part the ways.
No, but we must talk a lot more. I'm totally fascinated by this. So there are lots more areas to explore.
Maybe as a conclusion, I thought, just came up with the idea, you could mention some, for people who are interested in it, you could mention some good resources which could give a beginner, a glimpse into what is happening.
I would mention a book by Eric Kandel called In Search of Memory as a very good book to sort of start to get an idea of how a proper scientist spent 50 years from the 1950s till he won the Nobel Prize, doing the most simplest experiment on a sea slug in California to work out the actual basic biology of memory. And I think that I'll only recommend one. I'll recommend that book as my first recommendation. That gives a really nice picture of proper science, proper neuroscience, and how much effort it takes. There are many others, but I'll just leave with that one.
I think that's a good idea because you remove the choice from people. So I guess if somebody wants to read something, he'll go to that book.
I think that's a good start.
Excellent. Then I have nothing left than to thank you for your time and your passion and all the knowledge that you shared today with me and everybody else. Thank you, Wally.
A lot of fun.
Great.
Bye.
Goodbye, everyone.